Before you get started, it's a good idea to draw out your design. If you'll draw it out, it'll give you an idea of the scale of the tubing, and it'll save you time inside the CAD software when you're trying to determine the length of the tube, how it's going to look, how it should go together in assembly view. It'll save you a lot of time. So this is an older design here that we've already flown. We know that it works, but we made some adjustments. And then we decided we needed to shorten the frame based on the first flight, which we did. And that allowed us to get these hoop segments to be the same length. So we have a really good general idea of all the parts that we're going to need. But if you'll draw this out before you go into Onshape, it'll save you a lot of time inside the software. It'll save you money on printing out small scale. It'll also save you money on buying the aluminum tubing, because you'll have a really good estimate of what you're going to need when you actually purchase materials. So over here is the older design. This is the tubing that we needed. This is the connections. But since we made some adjustments, this is the new tubing based on the lengths that we would need, based on the new adjustments, and the connections. And so we can go in, get an idea of how everything is going to assemble. And if you need any tools, like just your basic school compass will help you get a nice straight circle. Any type of ruler will work to give you straight lines when you're drawing it. Protractor is useful for angles. And I also drew it out on side view. You notice my scaling on each one of these with the 56-inch hoop. So I drew it out to scale to make sure everything is proportional and it's going to look the way that we want. Now, there are other ways. If you're starting from scratch and you have no idea the length of tubing, not only can you estimate that based on what you build inside of Onshape, but you can do this with a little bit of math. Onshape will give you a degree for the hoop segment when you create it, because you're using revolve. But we need to know the length of the tube. What does that mean in length of the tube? Well, we can use this arc length formula, follow the process, and it tells us that hoop length for a 90-degree segment should be 43.96 degrees. Now, there's another way to estimate that. And so we can use this circumference formula to back up and check and verify this step. Just a different formula, very similar process. So we have two formula options, one for diameter, which we know, and one for radius, which we know. If we have diameter, we just cut that in half. So we went through to see if it gave us the same results as this one did, and it did. 43.96 for both of those. Now, there are other parts that we have that have bends in those, and it can be difficult to determine what is the straight length we need. So something like the back frame tube, the top harness tubes, or the swing arms, they're going to have curves in those. So there are going to be parts where we have trouble determining what the straight length is, even within the software. So we can use this formula here if we know the die. So what we're using to bend, we determine that radius from the inner part of that die to the outer, and we can estimate radius of the bend. For us, it was 3.5 inches for our bend radius, or 88.9 millimeters, and that's from the center to the outer edge of that die. We plug it into the formula, and it tells us for a 90-degree bend, we should need about 5.49 inches, or 139.57 millimeters. Very useful for swing arms, for the top harness tubes, the back frame, anything with a bend in it. We just need to know the degree, which we can find that out in Onshape. I like using graph paper because each one of these represents 2 inches. And so it gives me the ability to say, okay, I need about 22 inches here. The squares on the graph paper and the scaling to get an estimate of what the true length would be, or an estimate of the true length. The major formulas that we're going to use, obviously we'll use scaling inside Onshape because we're going to build a small scale. This is where you should start. You should go old school, draw it out on paper, because then you'll have a really good idea of what you're going to build inside of Onshape. Otherwise, you're going to waste a lot of time in your CAD program, not only if it's new to you trying to learn it, but try to build these out and then check to see if it fits in assembly view and then going back out and scaling it out. This will save you a lot of time within the software.